imagine you were tasked with creating HTTP request handler for the web application. In the main method of the application, we receive HTTP request, and then depending on the HTTP method, and that could be post, get, put or delete, we decide what we will do with this request. For example, when receiving post request, we add new user, and when receiving get, we will return user specified in the request. Of course, in this simple example, we will just print the user to the console. And this is how the HTTP request class looks like. Before adding new user, we have to verify if the client sending us this request is even authorized. We also have to check if the method is post, and if so, do we have the body to process. And also we have to verify this body content type. To achieve that, we have class request handler that validates the request. When the header map does not contain authorization key, we throw exception. Similarly, when there is no body or no content type. And what is wrong with this simple solution? If you watch my videos for some time, you probably can already guess. This is very naive approach that will only work for one HTTP method. And as soon as we have to change the requirements for different method, we have to copy this code every time. For example, for getting the user, we don't have to, for example, validate if the user is authorized. So this code is not reusable and not flexible. If the requirements for validation grew, we would also have a very long method full of if and else's. And this approach does not follow the single responsibility and open-closed principles. To fix this problem, we will use the hero of today's episode. And this is the chain of responsibility design pattern. This time I prepared two UML diagrams. We have our request that is handled by the chain of handlers that will finish the execution if there is some problem, or give the request to the next handler, and the last handler will give the request to the consumer. For example, in our application, endpoint adding a new user. In the second diagram, we have class representation and we have handler interface with handle method that is then inherited by the abstract base handler with the next field, set next method, call next method, and a static chain method that will chain our handlers. And this base handler is then inherited by the concrete handlers that will implement all the functionality. If you are a backend developer, you might notice that this is a very similar concept to something called middleware in many frameworks. So in our implementation of this pattern, we will call it middleware. So we will start our implementation with creating a middleware interface. So yeah, middleware, Java. Yes, and this interface will have a public void method handle that will get the HTTP request and will throw exception. Next, we will create the base middleware class. And obviously that will be abstract class that will inherit from the or implement the middleware interface. Now we will declare the private base middleware next. We will create protected method set next. This next equals next, obviously, and protected void call next. That will get HTTP request, and it will, if the next is not null, so this next is not null, it will call handle method on the next handler. And that obviously throws the exception Next, we'll create the public static method to chain our middlewares. So public static middleware that will get, of course, chain that will get multiple middlewares. So base middleware dot middlewares. And now we have to check if our middlewares are equal to null, or if middlewares.length is equal to 0. And if so, we will throw exception. So throw new illegal argument exception, because we need at least one middleware for this method to work. Okay, now for every middleware in this list, we will add new middleware as next. So middlewares.i set next middlewares I plus 1. And we'll return the first middleware. So middlewares dot 0. Not dot, but like the array syntax. Now that we implemented the base middleware, we will implement our concrete middlewares. So we will start with the authentication middleware. So out middleware Java class, and this will extend the base middleware. We obviously have to implement the method, so implement the handle, and we will just copy it from the request handler. So copy this, and if this method passes, we will just call next and pass the request. We'll do the same thing for the JSON content type middleware Java. We also have to extend the base middleware, and we have to implement the method handle, and we will also copy it from the request handler. And then we will just call next with the request, and we'll do the same thing for the body middleware. And we will also copy it from the request handler. And call next. Okay, now we can just delete the request handler, so I will just delete. Okay, after all of this hard work, we can now replace our part of our method in the main method. So instead of using request handler, I will just delete that, and we will call base middleware dot chain, and here we will chain our middlewares, but I will just format this part of code, and new out middleware, then new JSON type middleware, and this is weird, and new body middleware, and at the end of that we will just call handle the request. Nice. Technically, our consumer method should also inherit from the base middleware, so we could chain it in the middleware chain to make it more similar to the real-life frameworks, but for this example, I think this will be sufficient. If you have written all of this code with me, as a homework, I want you to create a middleware chain for the get method. Here is my last video about the result pattern that you can use to upgrade this project that we did today even further. And till the next time, create some amazing applications.